All right, we're going to go over the second half of chapter 8, the practice test for that. So, let's get started. Now, the key thing for this test is you need to know your identities and your trig values from the unit circle, as well as the range of each of the inverse trig functions. So, let's see here. Okay, so the first section of the test, you're going to be solving trig equations. So number 1. So the directions are solve for theta, where theta is between 0 and 2 pi inclusive, which means, of course, you got to give your answer in radians then. So first equation, 2 cosine theta plus 1 equals 0. So this is easy to get the juices flowing. So isolating the cosine, you get 2 cosine theta equal -1. Divide by 2, cosine theta equal -half. And that's a number you're supposed to know. So cosine of what angle is -half? Where would that be? Dunk, dunk. 2 pi over 3, 4 pi over 3. So that's why you have to know your unit circle. Otherwise, no can. Number 2. 4 sine squared theta minus 3 equals 0. So 4 sine squared theta equals 3. Divide by 4. Sine squared theta equals 3/4. Square root both sides. So sine theta equals plus or minus square root of 3 over 2. Don't forget the plus or minus now, because that's going to cost you, because if you don't put plus or minus, you lose half the solutions right there. So where is sine either plus or minus root 3 over 2? So that would be either here, here, there, or there. And you know what a good strategy is for maybe a lot of you is maybe you should draw the unit circle, since you have 55 minutes on this test. Draw the whole unit circle on your paper, and then so you don't make any mistakes. So theta is equal to, what's that one? This is the pi over 3 family, right? Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Except that's not 2, that's A, fool. Except it's B. C. Tangent 3 theta is equal to -1. Now, this number, is that a number you're supposed to know for tangent? Yes. So, all you do is you think, okay, think of this as just an angle measurement. Tangent of what angle will give you -1? So the tangent of what angle is -1? That would be here and there. So that would be 3 pi over 4 and 7 pi over 4. However, since the variable is 3 theta, you have to go 3 times around the unit circle. You got to remember that for this problem now. So if it's 2 theta, you go 2 times around. If it's 4 theta, you go 4 times around. In this case, we're going to go 3 times around. So this is just 1 time around the circle, so you have to go another time around. So how do you do that? You add 2 pi to each of these, because 2 pi is once around the unit circle. So adding 2 pi, and again, 2 pi is 8 pi over 4, right? If you make the least common denominator. So adding 8 pi over 4 to each of these, 11 pi over 4, 15 pi over 4. That's 2 times around. Now you got to go another time around. So add another 2 pi to both of these. So adding 8 pi over 4 to this, you get 19 pi over 4 and 23 pi over 4. Now, why are we doing that? Because to solve for theta, you have to divide by 3. So now, if you divide both sides by 3, which is like multiplying by 1/3, you will get pi over 4, 7 pi over 12. Yes? I'm recording a lesson here.
I know, sorry.
Can you come back in like 30 minutes?
Okay, it's about the test today.
Okay, come back in 30 minutes.
Okay.
11 pi over 12. Divide that by 1/3. The 3 cancels out. 5 pi over 4. 19 pi over 12. 23 pi over 12. So if you only give these two, see, you're losing 4 solutions, therefore you lost 4 points on this. So you gotta go 3 times around. So remember that for that problem. D, cosine theta plus 1 is equal to 2 sine squared theta. Okay, now these problems, now you're gonna have to start using identities to solve the problem. So, sine squared theta, what can I do with that? Well, use the Pythagorean identity, 1 minus cosine squared theta. Multiply out everything, cosine theta plus 1 is equal to, distribute the 2 minus 2 cosine squared theta. And this is a quadratic. Now, on your bonus quizzes, oh my goodness, I saw all kinds of atrocities. When you have a quadratic equation, you need to make one side 0. It can't be anything else except 0. 2 cosine squared theta plus cosine theta minus 1. Bring everything to the left side of the equation so the first term is positive. And then you should be able to factor it, because otherwise you can't do the problem. 2 cosine theta, 1 and 1, that's a plus, that's a minus. So if something times something equals 0, that means either this one is 0 or that one is 0. So what would make this one 0? Cosine theta would have to be 1/2. And in this one, cosine theta would have to be -1. And see, these are numbers we're supposed to know. So cosine of what angle is 1/2? That would be here and there, right? Because cosine is positive in the first and the fourth quadrant. Where is cosine -1? That would be there. So what are all of these? Well, these two here, that's pi over 3 and 5 pi over 3. See, that's why if you drew the unit circle on your paper before you even start this test, you can just kind of look at it there. And then boom, pi. All right. Okay, let's move up the thing. How many more we got here? We got 4 more. Okay, next one is E. 2 secant theta is equal to tangent theta plus cotangent theta. Mr. Park, these are all ones I don't like. Then what do? Change everything to sine and cosine. So 2 and secant is 1 over cosine. Tangent is sine over cosine. And cotangent is cosine over sine. So if you have an equation with fractions in it, what did your teacher teach you to do? Multiply both sides by the least common denominator, which is sine theta cosine theta. So if you do that, so this times this, the cosines cancel out, so you get 2 sine. This times this, the cosines cancel, so you get sine squared. And then this times this, the sines cancel out, and you get cosine squared. And then you go, hey, you somebody. That's right, that's 1. So sine theta equal 1/2. Hey, that's a number I'm supposed to know. And if you have your unit circle drawn on your paper, you just look at it, otherwise keep on drawing. Where is sine 1/2? Either there or there. So that would be pi over 6 and 5 pi over 6. Okay. F. Sine 2 theta equal cosine theta. Okay, we did this one on the homework. We did it on the okay, anyway, you have to use identity. Sine 2 theta. 2 sine theta cosine theta. So replace it with the identity. And should I cancel cosines from both sides? Don't you dare. Because you just lost 2 solutions by doing that. So what do? You make one side 0. If you have any questions about what to do, make one side 0. Okay? Factor out the cosine and what's left? 2 sine minus 1. And then that's what we want. We want something times something equals 0, because that means either this is 0 or that is 0. So what would make that 0? Well, cosine theta would be 0. And what would make this one 0? Sine theta would have to be 1/2. And these are all numbers we're supposed to know. Cosine of what angle is 0? Pi over 2, 3 pi over 2. Sine of what angle is 1/2? We just did that on this problem right here. So that's pi over 6, 5 pi over 6. And there you go. Do not cancel a variable from both sides of the equation. You lose solutions. G, cosine 2 theta is equal to cosine. Now, of course, if you're going to have a problem with sine 2 theta, you're going to get one with cosine 2 theta. Now, this one, there's 3 identities. Which one am I going to pick? Well, if that's cosine, you're going to use the one with cosine. If that's a sine over there, then use the one with sine. So cosine 2 theta, now again, grading the bonus quizzes, some of us don't even know the identity for that, so that this problem is gone already. 2 cosine squared theta minus 1. And then it's quadratic, so you make one side 0, bring everything to the left, and then it's gonna factor. So 2 cosine theta, 1 and 1, that's a minus, that's a plus. And again, we got something times something equals 0, that's good. Cosine theta would have to be negative half or 1. And again, these are all numbers we're supposed to know. Where is cosine negative half? Where is cosine 1? So where would that be? So this would be 2 pi over 3, 4 pi over 3. And where is cosine equal to 1? That's 0 and 2 pi now. Notice that it does include 2 pi, so you have to put... So basically, if 0 is an answer, then 2 pi is an answer as well. Okay, let's see if we can fit this one in. H, tangent 2 theta is equal to 3 tangent theta. So first order of business, regurgitate the double angle identity. 2 tan theta all over 1 minus tangent squared theta equal 3 tangent theta. When you have fractions within an equation, you multiply both sides by the least common denominator, which is 1 minus tangent squared. So 1 minus tangent squared. Fit it in there. Okay, so this times this, the 1 minus tangent squareds cancel out, and you only have 2 tangent theta left. And then this times this, you would have to distribute, so you get 3 tan theta minus 3 tangent cube theta. Now, anytime you have a quadratic or a cubic or a higher power equation, you have to make one side 0. So let's bring everything to the left. 3 tangent cube theta, bring that over, minus tangent theta equals 0. And then you factor it. So what do we got? I can factor out a tangent theta. What's going to be left? 3 tangent squared theta minus 1 equals 0. So again, we got to where we want to be. Something times something equals 0. That means either this one is 0 or this one is 0. Now, if this is equal to 0, that means tangent squared theta must be 1/3. Square root both sides. Tangent theta is equal to 1 over radical 3 plus or minus. Do not forget the plus or minus, people, because you just lost 2 solutions by doing that. And these are all numbers we're supposed to know. Tangent of what angle is 0? Here, here, and there. Here, let's just write them out. So that's 0, pi, and 2 pi. And where is tangent plus or minus 1 over radical 3? That's the pi over 6 family, yeah? Like that. So that's pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Woo! Okay, so that's the first page of the test. That's all solving equations. Okay, now the next problem, you have to use your calculator. Okay, let me get my calculator with me. Now, it doesn't matter what calculator you have, but if you read the directions in this problem, it says solve for theta. It says theta is between 0 and 360 degrees. So that means we need to be in degree mode. Okay? So let's erase this. Yeah, taka taka ta. Yeah, taka taka ta. Yeah, taka 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 taka. Okay, so here we go. So let me make sure I'm not in degree mode, so I'm gonna change it. Okay. So here's the first problem. 2a cosine theta is equal to 2/3. Okay, now this is a positive number. So the first thing you ask yourself, Cosine is positive in what two quadrants? First and the fourth. So there's going to be two answers, okay? Now, how do you get the two answers? Well, first what you do is you get the reference angle, okay? Now remember, how do you figure out the cosine of what angle is 2/3? This is what you punch in on your calculator. Cosine inverse 2/3. So this will give you the angle in the first quadrant whose cosine is 2/3. So you punch in cosine inverse 2/3. Now when we first learned this, we did it before we studied inverse trig functions. But now that we know inverse trig functions, we know this means the cosine of what angle is 2/3. Then that's why we did it. So if you punch that in on your calculator, you get 48.190 degrees. And again, if you use a calculator, you gotta round off to 3 places. Okay, so once you get the reference angle, if we want the first quadrant angle, that's it. That's it. So the first angle is the reference angle. Reference angle is always the first quadrant angle, 0.190. Now, how do we get the one in the fourth quadrant? Remember I gave you guys the thing, I gave you like a list of what to follow. If you're in the fourth quadrant, okay, here. If you draw the reference triangle, see, if this angle is 48.190 degrees, then of course that's 48.190 degrees. But if this angle here is 48.190 degrees, what is the angle going all the way around to there? Wouldn't it be 360 minus 48.190? Yes. And then I'm just gonna, you guys can punch that in your calculator. So just as a review then, if it's in the first quadrant, then you just use the reference angle for now. If you're in quadrant 2, then what do? You go 180 minus the reference angle. So quadrant 2, 180 minus the reference angle. How should I call that? Theta reference? No, how about theta r? Yeah, like, yeah. Quadrant 3. If you have a third quadrant angle, then you go 180 plus the reference angle. I don't know, capital R looks better, yeah? And then if you're in the fourth quadrant, then what you do is you go 360 minus the reference angle. Here, I'll box it just like I did when we did the homework. Okay? Okay, now what about part B? Now these are the only 2 problems you're going to be using your calculator on now. Cosecant theta equal -4. Mr. Burke, I don't like cosecant. Then change it to cosines and sines. Cosecant is the reciprocal of sine, so this means the same thing as the sine of what angle is -1/4, right? The reciprocal of -4 is -1/4. Okay, so to get the before we start, let's figure out what quadrants are we in. Sine is negative in the second and the fourth quadrant. Okay, so let's get our reference angle. So how do I get the reference angle? You punch in sine inverse 1/4 on your calculator. So even if this number is negative, you take the absolute value to get the reference angle, because reference angle is a first quadrant angle. So punch that in on your calculator. So sine inverse, where's my sine inverse? 1/4 is, boom, 14.478 degrees. Rounded to 3 places now. So once you have the reference angle, how do I get the one in the second quadrant? You go 180 plus the reference angle. See, this is the reference angle right there, so 180 plus that. So the first answer is 180 plus 14.478 degrees. And then how do I get the one in the fourth quadrant, just like back here? You go 360 here. Like, here's the reference angle. How do you get the angle going all the way around? You go 360 minus the reference angle. And I think we can punch that in our calculators, right? Or you don't even need calculators for this, but whatever. All right, so those are the 2 problems that require a graphing calculator, or not any calculator for that matter. It doesn't have to be graphing. Okay, next 4 problems. You're going to have to compute inverse trig values, which means you need to know the range. So here, I'm going to do it one more time. So the only 2 ranges you got to remember are between 0 and pi, and -pi/2 to pi/2. Now, which ones go here? See, look at the the odd, the one with an odd number of c's. So that would be cosine inverse, secant inverse, and cotan inverse. The other three go here. Okay, so that would be sine inverse, cosecant inverse, and tan inverse. Okay, here we go. First problem. 3a. Cosine, and remember I told you I'm only going to make a few problems on the test where this is a negative. That's when you got to worry about the range, because if this is positive, it's going to be a first quadrant angle. So what does this mean? Cosine of what angle is negative root 2 over 2? Okay, that's a number I'm supposed to know. But your answer has to be in the range. See, the range, cosine inverse, this is the range. So on your unit circle, where is cosine negative root 2 over 2? Well, it's either 3 pi over 4 or 5 pi over 4. But which of these two will lie between in the range over here? There's only one now. Don't give me more than one answer. There can only be one answer. Yes, it's 3 pi over 4, or 135 degrees. At this point, I don't care whether you give me radians or degrees, I'll accept either. I prefer radians though. Okay, B, sine inverse negative half. So what does that mean? Sine of what angle is negative half? But the answer has to be in the range. How did you know to use that range? Because duh, it's right there. Okay, so let's draw it. See, that's why if you have your unit circle drawn on your paper already, you just keep referring to it. Where is sine negative half? It's either there or there. So that's either 7 pi over 6 or 11 pi over 6. Now, which one of these lie in that range? None of them. So what do I do, Mr. Park? Well, you can add or subtract multiples of 2 pi from each angle. What would happen if I subtract 2 pi from that? You get negative pi over 6. Is that in the range? Yes, so that's why that's the answer. Okay, so keep on going. C, tan inverse negative 1. So again, what does that mean? Tangent of what angle is negative 1, but the answer gotta be in the range. Okay, now where is tangent negative 1? That would be here and here. That's 3 pi over 4 and 7 pi over 4. But neither of these is in this range here, so what do? We gotta add or subtract multiples of 2 pi. So this one here, if I subtract 2 pi from that, you get negative pi over 4. Is that in between here? You bet your bit-bee it is. Negative pi over 4. Because the range goes from negative pi over 2 to pi over 2. So it's either going to be the fourth quadrant or the first quadrant one. And since it's negative, it's got to be in the fourth quadrant. So that's the one I want to subtract 2 pi from. Okay, D. Cotan inverse root 3. Okay, so cotangent of what angle is equal to root 3? Oh, I don't need there's no negative there, so that's easy. This is going to be a first quadrant angle. Well, Mr. Park, I don't like cotangent, then change it to tangent. So if you take the reciprocal of both sides, then you get this. Tangent of what angle is 1 over root 3, and you got to be in the range. And here, I'll write the range again. The range, this is the original problem, so the range is 0 to pi. Because it's cotan inverse, not tan inverse now. Okay, so where is tangent 1 over root 3? Well, it's either here or there. But again, we want the first quadrant angle, so it's this one, which is pi over 6. So like I told you, if this argument here is positive, then the answer is a first quadrant angle, then you don't even have to worry about anything. So it looks like 3 out of those 4 are going to have a negative argument, right? So then you got to really think about the range. I'm recording. You got to come back in like 10, 15 minutes. Okay, we got some more problems here. Oh gosh. E, sine of tan inverse 3/5. Now remember, this is an angle measurement if you want to call it theta. Okay, so don't pay attention to the sign. Is that a number I know for tangent? No, so what you gotta do is draw up a picture. Tangent of what angle is 3/5? So what is tangent? Opposite over adjacent. And then using the Pythagorean theorem, that'll be the square root of 34. Do not put 4 there. Now, all you have to do is take the sine of this angle. Well, look at that angle. What is the sine of this angle? Opposite over hypotenuse. 3 over root 34, I'll take that right there. Easy, just draw the triangle and figure out the value. F, let's see if we can squeeze it in here. Tangent of cosecant inverse 17 over 8. Okay, this is an angle. That's not a number I'm supposed to know, so you draw the picture. Cosecant of what angle is 17 over 8? I don't like cosecant, so that's the same thing as saying sine theta is equal to 8 over 17. Okay, that I can handle. Sine is opposite over hypotenuse. And then if you use the Pythagorean theorem, 8, 15, 17. If you remember your Pythagorean triples, it'll save you time. Otherwise, you got to use Pythagorean theorem. Okay, and so once you draw a triangle, what is the tangent of this angle? Opposite over adjacent. So all you have to know is, so basically for this part here, you got to be able to draw the triangle and then no SOHCAHTOA, and then you can do it. Easy. Okay, and then the next problems, you're going to have to use identities to get your answer. So here's G. Cosine of sine inverse 3/5, we need to draw a triangle for that one. And tan inverse 5/12, we need to draw a triangle for that one. So this is an angle and this is an angle. Both of them we don't know off the top of our head, so we need to draw a triangle. So here's alpha. Sine is opposite over hypotenuse, Pythagorize. Okay, and here's beta. Tangent is opposite over adjacent, Pythagorize. And since they're positive, see positive argument, they're all first quadrant angles, so you don't have to worry about where to draw it. Just first quadrant. Now, how do you take the cosine of something plus something? You gotta use identity. Do not distribute. Cosine of the first, cosine of the second, minus sine of the first, sine of the second. So you regurgitate the identities, and then you just look at the triangles that you drew. Cosine of alpha, adjacent over hypotenuse. Cosine of beta, adjacent over hypotenuse. Sine of alpha, opposite over hypotenuse. Sine of beta, opposite over hypotenuse. And right there, you just got yourself 4 out of 5 points. And then simplify it. 48 over 65 minus 15 over 65. That's 33 over 65. Okay, H. Sine of tan inverse 3/4, that's ugly, plus cosine inverse 1/3. So this looks like almost the same problem. So both of these we don't know. We'll call that alpha and beta. So draw triangles. So alpha. Tangent is opposite over adjacent, and then Pythagorize. This one here we'll call beta. Cosine inverse. Cosine of what angle is 1/3? Adjacent over hypotenuse. And using the Pythagorean theorem, that's 2 root 2. Radical 8. Make sure you do that part correctly. And then now, what is the sine of alpha plus beta? You just regurgitate the identity. Sine out, sine of the first, cosine of the second, plus cosine of the first, sine of the second. And then you just look at your triangles to fill in these values. So alpha, sine alpha, opposite over hypotenuse. Oh, that's too small. Cosine beta, adjacent over hypotenuse. Cosine alpha, adjacent over hypotenuse. Sine beta, opposite over hypotenuse. And then you just compute that. Okay, do we need to compute that? Okay, I will. So what is that going to be? This is equal to 3 over 15 plus 8 root 2 over 15. So the final answer will be 3 plus 8 root 2 over 15. Not all the answers can come out nice. 2 more problems to go, I hope. I. Cosine of 2 tan inverse 2/3. Okay, so this is an angle measurement, and again, that's not a number I'm supposed to know, so you draw the triangle. Tangent of what angle is 2/3? Opposite over adjacent, and then using the Pythagorean theorem, that's root 13, right? Okay, so cosine of 2 theta, you gotta use identity. Now there's 3 identities, I don't care which one you use, it doesn't matter. My favorite is cosine squared minus sine squared. You can use, if you want to use 2 cosine squared minus 1, or 1 minus 2 sine squared, it doesn't matter. You're gonna get the same answer because they're identities. So looking at the picture, cosine is adjacent over hypotenuse, but then you gotta square it. Sine theta is opposite over hypotenuse, but you gotta square it. And there you go, 4 out of 5 points, and then now you just gotta simplify. 9 over 13 minus 4 over 13 is 5 over 13. Easy money. And then finally, J. Tan of 2 cosine inverse 3/5. And again, that's not an angle I'm supposed to know, so you think of that as theta, you gotta draw the triangle. Cosine is adjacent over hypotenuse, and then you use the Pythagorean theorem. Another 3, 4, 5 triangle. Now, tangent of 2 theta. There's an identity for that. 2 tangent theta. Now, I think we got 2 more problems because we've got to do half angle identity. 1 minus tangent squared theta. So all you have to do is look at the picture. What is tangent theta? Opposite over adjacent. So 2 times opposite over adjacent, all over 1 minus opposite over adjacent squared. 4 out of 5 points right back. So what is that? That's 8/3 over 1 minus 16 over 9. Multiply top and bottom by 9. So that's going to be 24 over 9 minus 16, which is 24 over negative 7. Katoosh! So again, what are we doing? We're writing down the identity and then just looking at the triangles, right? This is not difficult. It takes a little bit of practice. Okay, well, I think now we only have 2 more problems. Let's get it done! Are these the last 2? Yeah, hallelujah! It is. Okay, so K. What do we got here? What do we got? Sine. So yes, the last 2 problems are half angle identities. Tan inverse 24 over 7. So, don't pay attention to this. This is an angle. Tangent of what angle is 24/7? I don't know now. Draw the picture. Tangent of what angle is 24 over 7? Opposite over adjacent. That angle right there. Use the Pythagorean theorem. Again, 7, 24, 25. If you don't know, then just do the Pythagorean theorem. Now, what is the sine of half of this angle? So, first step, regurgitate the identity. Plus or minus the square root of 1 minus cosine theta all over 2, right? That's the identity for sine of 1/2 theta, or theta over 2. Next step, figure out plus or minus. Well, if you have a first quadrant angle in the first quadrant, and you half it, it's still in the first quadrant. So sine of a first quadrant angle is positive, so it's going to be positive. And then you just look at this triangle for that. Cosine theta is adjacent over hypotenuse. 7 over 25, all over 2. Boom, 4 out of 5 points. Multiply top and bottom by 25. So inside the radical, what do we got? 25 minus 7 over 50, which is the square root of 18 over 50, which reduces to the square root of 9 over 25, but both of those you can square root. 3/5. Beautiful. Huh? Oh yeah. L. Tan of 1/2 secant inverse 13/12. Again, you're gonna have to use half angle identity because this is half of an angle. So again, this is an angle measurement. I don't know it, so I'm gonna draw the picture. Mr. Park, I don't like secant. Well, that's the same thing as saying cosine of what angle. Here, let's just write it like this. Secant of what angle is 13 over 12, which is the same thing as saying cosine of what angle is 12 over 13. So cosine is adjacent over hypotenuse, and then you use the Pythagorean theorem. See how I'm using all the Pythagorean triples? Okay, so what is the tangent of 1/2 theta? So there's 3 identities, but remember what is the one I told you to know? 1 minus cosine over sine. This is the bestest one. If you don't believe me, try use the other ones then. Well, this one's not going to be too bad because there's no radicals in here. So actually, the other one without the radical would work just as fine. But if there are radicals here, then this is the bestest one. So 1 minus cosine. Cosine is, look at the picture, adjacent over hypotenuse. Sine is opposite over hypotenuse. And boom, there you go. That's 4 out of 5 points. Simplify for the last point. Multiply top and bottom by 13. And what do we got? 13 minus 12 over 5. 1/5! Yeah! All right, that's the last problem. All right. Tomorrow's test will look just like this. All you gotta do is be able to do it all by yourself without any notes. And that's the hard part.